All right, so it has been mentioned that numbers 13 and 14, there's a couple people who are struggling with it, so I'll make a video solving number 13, and then I also want to go through and solve number 15, because I think it's going to cause you some problems. Just an FYI, on all of these questions, they're all whole number answers. Not that you have to get a whole number, but for problems, but like these, you're going to get whole number answers. All right, so for number 13, my angle in question, it's all about the vertex. So the vertex that I have is on the circle. So if the vertex is on the circle, even if part of the angle goes outside of the circle, the vertex is on. So then I have an inscribed angle. So I can either say that the angle is equal to half the arc, or 2 times the angle is equal to the arc. I'm going to use this equation to help me solve it out because both of my angle and arc measurements are expressions. So if I double my angle, then that's going to equal my arc. All right, I'm going to distribute the 2. I'm going to subtract 22x from both sides. All right, I can subtract the 1 from both sides, and then I'll get my x value as 5. Before I circle my answer and know for sure, I'm going to plug it back in and make sure that it works. I'm going to do this the quick way with my calculator. So for my angle, I have 11 times x, which I think is 5, plus 3. So that would give me an angle measurement of 58 degrees. For my arc, I have 23 times x, which I'm going to use as 5, and then a plus 1, which would be 116 degrees. So my angle is in fact twice or half my arc. So 116 divided by 2 will give me my angle measurement of 58. All right, for number 15, the angle in question has a vertex that meets outside of the circle. So my vertex is outside. Anytime my vertex is outside, then the measure of my angle is going to be equal to the difference of the 2 arcs divided by 2. Or 2 times the angle is going to be equal to the difference of the arcs. The 2 arcs that I need to subtract, I always do the big minus the small. So here is my large arc inside of my angle. And here is my small arc inside of the angle. I know the angle measure is 65 degrees. I'm going to use this equation. So 2 times my 65 is going to be equal to my arcs subtracted. My arcs are algebraic expressions. I'm going to use parentheses. Parentheses are going to save you from making a common mistake. Because when I subtract this arc, 7x plus 4, I have to subtract the entire 7x and the 4, otherwise known as distributing the negative. So on the left side, I have 130. On the right-hand side, I can drop the parentheses if I distribute my negative to the 7x and to the 4. If I combine like terms on the right-hand side, I'll have 14x plus 4. I'm going to go ahead and subtract 4 from both sides. 126 is equal to 14x. When I divide by 14, let me just double check, I get 9. All right, so I'm going to plug in my 9 for my x values to make sure that my arcs are what they need to be. So 7 times 9 plus 4 will be the small arc, 67 degrees. And 21 times 9 plus 8 will be my larger arc, 197 degrees. So I'm just going to plug this in like I would up here with my 2 arcs subtracted. So 197 minus 67 from my 2 arcs divided by 2 should give me my angle 65. And it does. All right, let me know if you have questions.